Welcome to Maths with EJD. I've been taking you through a series of classes on matrices, and right now our attention is directed towards matrix inversion by solving systems of linear equations. Previously, we have considered matrix inversion by the minors and cofactors method, as well as the Gauss-Jordan method. Now, I think it's important to add this extra layer, which is matrix inversion by solving systems of linear equations. Okay, um, the whole idea of this is based on the fact that when you multiply a matrix by its inverse, you get the identity, and based on that, you can build something. So, of course, to find the inverse of a matrix A, which is A11, A12, A21, A22. I'm just using the 2 by 2 matrix as an example. It could be any dimension at all, 3 by 3, 4 by 4, all that. Then, of course, once you have that, then you remember that A inverse is equal to I, whatever the matrix is called. When you multiply it by its inverse, you get the identity matrix of the same order. Okay, so let's assume that. So in that case, you don't usually take A to be something, maybe A, B, C, D, or you can choose it to be X, Y, P, Q, whatever. So, and of course, this is the what you establish. This is the matrix you are given. This is the inverse you're assuming, which you do not know. And then this is the identity matrix, which you know. So based on this setup, you can now expand this and solve for A, B, C, and D. Once you solve for A, B, C, and D, automatically, it's as good as getting your inverse. And that is what this video is about. So let's get into it. First of all, we go for a 2 by 2 matrix. We have a 2 by 2 matrix this way. Say you have to find the inverse of R, which is 2, 3, 1, 4. 2, 3, 1, 4. So basically, you know that R inverse is equal to I. And of course, since this is R already, 2, 3 minus 1, 4. 2, 3 minus 1, 4 here. Maybe did I say 2, 3, 1, 4 the other time? It's 2, 3 minus 1, 4. And then this is A, B, C, D. So A, B, C, and D are representing the elements of the inverse matrix. And then this is the unit matrix. So, and what do we do? Like you've been told already, you expand this, you expand. So how do you expand that? It's like you're multiplying normal multiplication of matrices. So, and of course, you already know this is a 2 by 2 matrix to be multiplied by a 2 by 2 matrix. So, of course, because of these two rows, you write AC twice, BD twice. So you have AC, AC, BD, BD, and then you go ahead to now invert the rows of the first matrix on this. So that's 2, 3, 2, 3, 2, 3, and then 1 minus 1 4, that's minus 1, 4, minus 1, 4. So with that now, of course, that's equal to the unit matrix. You keep that. And then the next thing is you multiply 2 times A is 2A, 3 times C is 3C. So you have 2A plus 3C here. You have 2B plus 3D minus A plus 4C minus B plus 4D, and all of that is equal to the unit matrix 1, 0, 0, 1. So the next thing to do is to equate elements, corresponding elements. So this is 1, 1 here. So it is equal to this. 2A plus 3C equals 1 here. 2B plus 3D equals 0. That's what you have here. Minus A plus 4C equals 0. That's what you have here. And minus B plus 4D is 1. And that is exactly what is here. So you can see that having done all the equations, you discover that you have 4 equations. So, and these two, the ones in this column, are both in A and C. So you can solve simultaneously to get A and C. Here you have B and D. They are in terms of B and D. So you can solve those simultaneously and get B and D. And of course, from high school mathematics, you already probably understand the idea of elimination method. So the idea of elimination is to, find a way of removing one of the two. Here, for instance, you have A and C. If you can remove A or C, so you can find. So, for instance, what I'm doing here, I'm eliminating A so I can find C. Once I find C, then I take it back and I look for A. Okay. So I'm eliminating A, I get C. Then I use the value of C into the equation. I put the value of C into the equation and then I get A. All right. So here, I already see that this is 2A and this is minus A. So it's pretty easy to just multiply this equation 2 by 2 so that I have 2A here and minus 2A here. So once I add that up, 2A minus 2A will just cancel out and I'm left with C, which is very nice. So, and that's why I just say equation 1 multiplied by 1 because I don't want anything changed. So I have 2A plus 3C equals 1. That's for equation 1. For equation 2, because I want this place to be 2A also, so I can easily add. So I multiply equation 2 by 2. So I say 2 times minus A, that's minus 2A. 2 times 4C, that's 8C. 2 times 0 is 0. So now we are set to eliminate A. So, and what to just eliminate A, we can add. So, because this is 2A minus 2A. So, if you add the 2A plus minus 2A, that's 2A minus 2A, which is 0. So, that will go. And then you can add 3C plus 8C, that's 11C. 1 plus 0 is 1. Divide through by 11, 11, 11. So, C is equal to 1 over 11. So, easy. Now that you've got C, then you can go back. So I now say from equation 2, this equation 2 now, or you can use equation 1. Anyone you choose is fine. So but I can see equation 2 is easy because I don't have to worry about 1. This is 0. And it looks simpler. So you can, if you use 1, you also get the same result, right? But one of the ways to know a smart student is you go for things that will make your life easy, not things that will complicate your life, okay? So from equation 2, which is minus A plus 4C equals 0, then I already have C to be 1 over 11. So I just say minus A plus 4 into 1 over 11 equals 0. And then I have I have I have minus A plus 4 over 11 equals 0. So I can transfer 4 over 11. So I have minus A equals minus 4 over 11. Then A is 4 over 11. So now I have A and C. So let's go and look for B and D. We are looking for A, B, C, D. So we have A and C. So let's look for B and D. So again, 2B plus 3D is 0. Minus B plus 4D is 1. So just like what we did in the other case. So I just have, so equation 3. I name this equation 3. Equation 3 multiplied by 1 because there's minus B here, there's 2B here. So I just need to keep this the way it is and multiply this by 2. So this multiplied by 1 remains exactly what it was. And then equation 4 multiplied by 2. So that's minus 2B. That's 2 times minus B. 2 times 4D, that's 8D. 2 times 1 is 2. And with that now, we can eliminate B. So by adding both sides, so if you add 2B plus minus 2B, that's 2B minus 2B, that's 0. And then 3D plus 8D, that's 11D. 0 plus 2 is 2. So D itself is 2 over 11. So, and now that you have it, you can use the easier of these equations. The easier one is obviously this because, well, I don't know, because I don't have to multiply something and start dividing. So, I mean, minus B is just straightforward. So I have, if you use anyone, you get the answer, don't forget. So it's not a rule that you must use 4. You can use 3, you can use 4. Either one is fine. So you have minus B plus 4D equals 1. That's what equation 4 is. And now that you have D to be 2 over 11, so you can say minus B plus 4D equals 1. Then minus B plus 4 into 2 over 11 equals 1. So 4 times 2 over 11 is 8 over 11. So minus B plus 8 over 11 is 1. So what I just did here is to move minus B to this side. So I have B, and then I bring 1. So it's 8 over 11 minus 1 over 1. And the LCM, of course, 8 over 11 minus 1 over 1 minus 1 over 1. The LCM is 11. 11 in 11, 1 times 8. That's 8 minus 1 in 11, 11. That's this. So 8 minus 11 minus 3 over 11. So with that now, we have got A, B, C, and D. We have A, B, C, and D. And we can state that. So A is 4 over 11. B is minus 3 over 11. C is 1 over 11. D is 2 over 11. And don't forget where we started from. We had the matrix R. And then we had A, B, C, D, which was supposed to be the inverse of R. And that's equal to I. And that's what brought us. So we can answer, therefore, R inverse is 4 over 11 minus 3 over 11, 1 over 11, 2 over 11. So you can take 11 out so to make things neater. So you have 1 over 11 into 4 minus 3, 1, 2. And that's why you have this. So it's so cool for 2 by 2. For 3 by 3, it gets a bit more tricky, or a bit more, maybe even boring sometimes. But let's just look at it. Of course, you have different methods, so you don't have to be fixated on this particular one. You can choose any method that works for you. You have the minors and cofactors method, and you have the determinant, you have the Gauss-Jordan method, you know. So you can actually always do that. So find the inverse of S, a 3 by 3 matrix now, which is 230 minus 145, 221. Again, the basic rule is SS inverse is I. So that means you have 230 minus 145, 221, from the original matrix. And then your S inverse now, you say that A, B, C, D, E, F, G, H, I. You can call it anything you like, something easy. And then now you're dealing with 3 by 3 matrix. So you need a 3 by 3 unit matrix on the other side for your I. That's 1 0 0 0 1 0 0 0 1. And of course, you need to do a bit more when it comes to adding and multiplying and summing things up, because this is 3 rows, right? You write ADG 3 times, ADG, ADG, ADG. Next, BEH 3 times, BEH, BEH, BEH. Next, CFI 3 times, CFI, CFI, and CFI 3 times. And of course, with that done, then you bring 230. That will go on the whole of the first row, and minus 415, minus 145 will go on the second row all through. 221 will be inverted on 221 on the third row. So with that, you just have to, and of course, you maintain the unit matrix 1 0 0 0 1 0 0 0 1. Okay, so now what you have to do is to now establish the equations. So you have 2a plus 3d plus 0, that's just 2a plus 3d. Same here, 2b, 3e, this is 0, 2b, 3, then 2c, 3f, you have that. Then you also have here minus a plus 4d plus 5g. That's what you have here. Then minus b plus 4e plus 5h. That's came here. Then minus c plus 4f plus 5i. That's it right here. 2a plus 2d plus g. This is it. 2b plus 2e plus h. This is it here. 2c, 2f, and I. This is it. And then all that is equal to 1 0 0 0 1 0 0 0 1. Okay. Now, the other time, okay, yeah, I mean, we just use normal elimination method, right? So here, things are a bit trickier. At first, I wanted to use, Gauss-Jordan method, but I discovered that if you want to use Gauss-Jordan method, it's as good as you solving the equation using Gauss-Jordan method in the first place. So that's why I just resolved to use elimination method again. So how do you establish these equations? You already know that. So 2a plus 3d is 1. That's it here. Then minus a plus 4d plus 5g is 0. This is it here. Then 2a plus 2d plus g is 0 here. Then you have 2b plus 3e is 0 right here. Then minus b plus 4e plus 5h is 1 right here. Then 2b plus 2e plus h is 0. That's right here. Then 2c plus 3f equals 0 right here. Minus c plus 4f plus 5i equals 0. This is 0. Then 2c plus 12 plus I equals 1. So you have set up the equations, 9 of them. That's a lot, Maybe it's not worth it after all. When you compare it with things like minors and cofactors and Gauss-Jordan and all the rest. But I mean, my method is I give you everything. I tell you everything that is available, so you can make your choice. You choose what you like. So let's focus on ADG first of all. Let's focus on this. All right. So how do you take care? You're looking for A, D, and G. So you have 2A plus 3D equals 1. Because because the coefficient of G here is 0, that makes things a bit easy, That makes things a bit easy. So now so we already have 2A plus 3D. So naturally, I just know that if we can eliminate G from one of these, then we can solve A and D together with this, and we get A and D. And once you get A, you can get D, then you can use A and D to get G. So, but if the coefficient of G here was not 0, it will be a bit more, a bit more complicated, so to speak. Okay, so I know we have two A and D. So I also want to find a way of getting just A and D from these two. And what did I do? I can already see minus. Okay, well, I want to get rid of G. You know, it's easy to get rid of A, but if you get rid of A, you have D and G, and then that doesn't match what you already have. So it's better to get rid of G, no matter how that is. So what I just do is I call this equation 1, equation 2, equation 3. So I multiply equation 3 by 5. Why am I doing that? I have 5G here. So this is G. So to get rid of the G's, I can multiply equation 3 by 5. So the both can be 5G. So I can easily subtract. You know, they have the same sign now, so you can subtract. If they have different signs, like plus minus, you add. If they have minus minus or plus plus, you subtract. So you can get 0. Okay. So equation 3 multiplied by 5, that's 2a times 5, 10a, 2d times 5, 10d, g times 5, 5g. And that's my equation 4 now. So what I'm doing next is to say, yeah. So now that this is there, the next thing I'm doing is, since we need A and D, right? The next thing I'm doing is to say 4 minus 2. That's this equation 4 that I've got now. I want to subtract that. I want to subtract it. I want to say 2 minus. I want to subtract equation 2 from equation 4, so I can get rid of G. That's the idea. So I say 4 minus 2. 4 minus 2 means subtract corresponding terms. So 10A minus minus A, 10A minus minus A, that's 10A plus A, that's 11A. Then 2D, okay, sorry, 10D minus 4D, that is 6D positive. Then 5G minus 5G, that is 0. So no G, that's what we need. Then 0 minus 0 is 0. So that by doing this now, I have eliminated G. So we can now look at how we can take care of, we can solve this and this together, because they both have terms in A and D. So we can solve them like a 2 by 2. So now what am I doing to take care of that? You see, this is already 6D and this is 3D. So I can easily multiply that by 2. So if we're going to eliminate A, so I would have had to multiply equation 1 by 11 and equation 5 by 2. So they can both have the same coefficient of 22. But it's easier. I can just multiply. This is already 6D, so I don't have to worry about multiplying it by anything apart from 1. Then I multiply this by 2 to bring it up to 6D. So, and if I'm able to do that, so you see, I say equation 1 multiplied by 2. So I have 4a plus 6d equals 1 times 2, 2. Then, of course, we already have 11a plus 6d. So 6d and 6d can easily take care of themselves. So next is to so I say 5 minus 6. That is this equation 5 minus equation 6. That means 11a minus 4a, 7a, 6d minus 6d, gone for good. So 0 minus 2. Careful, the minus has to appear. So 7a equals minus 2. So my a is minus 2 over 7. So that's so sweet. A is settled. So now that I have a, I can now put minus 2 over 7 for a in equation 5. I put 2 over 7 here, so I can get D. So equation 5 is 11a plus 6d equals 0. So that's 11a plus 6d equals 0. Now a is minus 2 over 7. So I have 11 times minus 2 over 7, that's minus 22 over 7 plus 60 equals 0. So 6d now. So I transfer this to the other side. So 6d is 22 over 7. That means that D is, D is 22 over 7 times 1 over 6. It's more like dividing both sides by 6, by 6, like that. So that, so 2 here is 11, and 2 here is 3. So 11 times 1 is 11. 7 times 3 is 21. So D is 21. So now we have A to be minus 2 over 7. D is 11 over 21. And then, so you can now put the values of A and D in equation 2. Actually, you can put it in 2 or 3, because now we are looking for G. We already have A and D. So you have G here, you have G here. So you can use either of the two. But like I told you, I always look for the one that is easier. So I take equation, I take 2, so that's minus a plus 4d plus 5g equals 0. So I have minus, a is minus 2 over 7. Be careful with minus. When minus is involved, be careful. So minus into minus 2 over 7 plus 4 into d, which I just got as 11 over 21, right? So now all that plus 5g equals 0. Okay. So minus 2 over 7, that's 2 over 7. Then plus 4 times 11, that's 44 over 21, plus 5g equals 0. So I take the LCM of this. 7 and 21, that's 21. 7 in 21, 3 times 2, 6. 21 in 21, 1 times 44, 44. So that's 50 over 21 plus 5g equals 0. So 5g is here, so you can transfer this to the other side. So you have minus 50 over 21. Divide both sides by 5. So that means g is minus 50 over 21 times 1 over 5. And g is minus 10 over 21. 5 here is 1, 5 here is 10. So you have minus 10 over 21. So with this, you have got A, D, and G. You've got A, D, and G. So we need B, E, and H. So the process is pretty much the same, So here I multiply 8 by 5 because I want to get rid of H. So that's 10B plus 10E plus 5H equals 0. And then the next thing I do is to say 9 minus 7. Okay. Okay. I think what is happening here, this is more like this is 10. So 9 minus 7, 9 minus 7. Okay, what's happening here? Let me see. I wrote 9 minus 7. So this is 11b plus 6e. No, this shouldn't be. Okay. I guess this, what did I write? This is 11b plus 6e. 11b plus 6e. How did that come about? I'm trying to figure that out. Minus 1. Okay, looks like I jumped. Did I jump a step or something? So equation 8 times 5, right? We have equation 8 times 5. No, it should be equation 9 times 5. Equation 9 times 5. Yes, this will be equation 9 times 5. Equation 9 times 5. 9 times 5. So this is 5 to 10b, 10e, 5h, 0. Okay. So the next thing is to get so this should be equation 10 minus 8. 10 minus 8. Yeah, that should be 10. This place is equation 10 minus 8. This is 10 minus 8. 10 minus 8. So that means 10 minus 8, that's actually 10b minus b, that's 11b. Then 10e minus 4e, that is 6e. Then 5h minus 5h, 0. 0 minus 1, minus 1. Yeah, so we're back on track. So the next thing is to multiply equation 6 by 2. Equation 6. Oh, this can be equation 6. Okay, it's equation 7 now. I think while I was preparing this, I made some changes without changing it all through. So this is equation 7 by 2 now. Equation 7 multiplied by 2. This 7 multiplied by 2. So that's 2 times 2b, that's 4b. 2 times 3e, that's 6e. 2 times 0 is 0. Okay. Now with this, the next thing is to say 11 minus 12. Equation 11 minus 12. So that's 11b minus 4b, that is 7b. 6e minus 6e gone. So minus 1 minus 0, that's minus 1. So that b itself, divide both sides by 7. So you have b equals minus 1 over 7. So the next thing is we put this value of b, we put it in 11. That seems to be the easier one in this case. So I have 11b plus 6e minus 1, this expression. So 11b plus 6 equals minus 1. So that's 11 into minus 1 over 7 plus 6 times e equals minus 1. So with this, we have 11 times minus 1 over 7. That's minus 11 over 7 plus 6 equals minus 1. So you can transfer this. So we have 6e equals minus 1 over 1 plus 11 over 7. So take the LCM of that. 1 and 7, LCM is 7. 1 is 7, 7. 7 times minus 1, minus 7. 7 and 11, 1 times 11, 11. So minus 7 plus 11 is 4. So 6e equals 4 over 7. That means e itself is 4 over 7 times 1 over 6. Divide both sides by 6. So 2 here is 2, 2 here is 3, so 3. So E is 2 over 21. So now we have B is minus 1 over 7. B is minus 1 over 7, as you can see from here. B is minus 1 over 7. Now E is 2 over 21. So the next thing we are doing is to put the values of B and E in equation 8. Remember, equation 8 is minus B plus 4E plus 5H plus 1, because we are now looking for H. So we put that minus B plus 4E plus 5H. So B is minus 1 over 7. That's why you have minus 1 over 7. 4E is 2 over 21, which we just got now. And then we are looking for H. So you have, this is 1 over 7 because of the double minus. So minus, that's 1 over 7, 8 over 21. Then 5H equals 1. Then what I did next is to transfer all the numbers to the other side. So you have 5H equals 1 over 1 minus 1 over 7 minus 8 over 21. And then with the LCMs, we have LCM is 21. 1 in 21, 21 times 21, that's 21. 7 in 21, 3. 3 times 1, 3. Minus 8, 21 in 21, 1 times 8, 8. So with that, we have 21 minus 3, which is 18. 18 minus 8, that's 10 over 21. Then we have to divide both sides by 5. So that's why we have 10 over 21 times 1 over 5. And the answer is 5 here 1, 5 here 2. So H is 2 over 21. So we have got B, E, and H. So we have to look for, we have to now look for C, F, and I. C, F, and I. Same process, same process. So 2C plus 3F equals 0 minus C plus 4F plus 5I equals 0. 2C plus 12 plus I equals 1. So I say 13 times 5. That's equation 13 times 5. Oh, okay. I think that's the same issue I had the other time. I think I changed some things without remembering to effect it. So what is actually happening here is actually equation 15. Equation 15, yeah, times 5. So equation 15 times 5. This is equation 15 times 5. So 5 times 10, 2C, that's 10C. 5 times 2F, 10F. 5 times I, that's 5F. 5 times 1 is 5. And then the next thing that is happening is equation 16 minus 14. 16 minus 14. 16 minus 14. So that's this minus this. So that's 10F, 10C minus C, that's 11C. 10F minus 4F, that's 6F. 5I minus 5I, 0, you know. So 5 minus 0 is also 5. So we can move on from there. So now we can multiply. So we have equation 13 and equation 17 having C and F. So we can solve them together. So that's why we said now equation 13, yeah, this is not supposed to be 11. So I say equation 13 now, equation 13 times 2, this equation 13 times 2. And that is because this one has 6. So if we multiply this by 2, we can have 6F for that. So 2 times 2C times 2, that's 4C. 2 times 3F, 6F. 2 times 0, 0. And you know, we already had 11C. We had 11C plus 6F. So we can solve these two together. So we can say 17 minus 18. That is we can say 17 minus 18. So 11C minus 4C, that's 7C. 6F minus 6F, that's 0. 5 minus 0, 5. So with that, we have C to be 5 over 7. When you divide through by 7, C is 5 over 7. Then you can put the value of C now in 18. You know, 18 has F. So you can have 4C. You know, you can actually put it here too. But I've already avoided this 5 because I'll have to subtract or add something. But this is just 0. So I have less issues to contend with. So as you're even solving the problem, maybe you should think of optimizing the process of your solution. So you have 4C plus 6F equals 0, right? And then this is so C is 5 over 7. So you have 4 into 5 over 7 plus 6F equals 0. So 4 times 5 over 7, that's 20 over 7 plus 6F equals 0. And then we have 6F equals minus 20 over 7. And you divide both sides by 6. So that's minus 20 over 7 times 1 over 6. 3 here is 2. 3 here. Oh, better still, 2 here is 3, and 2 here is 10. So it means F is minus 10 over 21. So now you have both C and F. So we have just I to go. And to do this, put the values of C and F in 14. You can put it in 14, you can put it in 15 because they both have I. So you can put it in 14 or 15, but because this is 0 and I don't have to worry about this one, because if I use this, I'll have to either subtract or add something later. So I just say 14, which is minus C plus 4F plus 5I, and that's what I bring down here. Minus C plus 4F plus 5I equals 0. So C that we got already is 5 over 7. So I have minus 5 over 7 plus 4. F is minus 10 over 21. Then plus 5I equals 0. So we have only the I to contend for. So this is minus 5 over 7. And this 4 times 10, that's minus 40 over 21 plus 5I equals 0. So next I have 5I, then I take all this to the other side. So I have minus 5 over 7 becomes 5 over 7, minus 40 over 21 becomes plus 40 over 21. So we can take LCM of those. So LCM of 7 and 21 is 21. 7 and 21 is 3. 3 times 5, 15. 21 and 21, 1. 1 times 40, 40. So you have 5I to be equal to 55 over 21. Then you divide through by 5. So I is 55 over 21 times 1 over 5. 5 here is 1. 5 here is 11. So I finally is 11 over 21. So, I mean, that has been such a tedious journey. Finally, you have got everything you need to get. So you remember that A is minus 2 over 7, B is minus 1 over 7, C is 5 over 7, D is 11 over 21, E is 2 over 21, F is minus 10 over 21, G is minus 10 over 21, H is 2 over 21, and I is 11 over 21. So that's the inverse you're looking for. That's the inverse you're actually looking for. So finally, you have that which you're looking for. So to make things tidier, you can just take out, you see 21 is the LCM of all the fractions, 7, 7, 21. So if you take 21 out, so you have 1 over 21. So anywhere there is 7, you have to multiply by 3, right? Because 7 goes in 21 3 times. So 3 times minus 2, that's why you have minus 6. 3 times minus 1, that's minus 3. 3 times 5, that's 15. That's the way to balance that up, because normally if you take the 21 back, minus 6 over 21 is 3 here, 2, 3 here, 7. So everything still works good. And then for the other ones that have 21, no worries. Just take out the 21 and maintain 11 to minus 10, like you have 11 to minus 10, minus 10 to 11, minus 10 to 11, like that. So with that, you have S inverse, which is the inverse of the S you started with. Okay, so you can try your hands on this to see how strong you are. Find the inverses of the following by solving systems of linear equations. M 0 minus 1 minus 3 1 minus 1 2 0 3 1 minus 1, and then you can call this N. Let's say this is N, like this. This is N equals 4 minus 1, 7 minus 2. So try your hands on that. Let's see if you can handle that. Thank you for listening always. See you in the next video.